Hey, we're going to talk about solving systems of equations using substitution. So the substitution property of equality says that if we know that two quantities are equal, we can substitute one for the other, either direction we like, because they're the same thing. We can put them in each other's place. So one way we could solve this system of equations is to say, well, I know what y equals 3x. So I'm going to take that, and instead of writing a y in this equation, I'm just going to put the 3x right there because they're the same thing. So that looks like this. Instead of y equals negative x plus 4, I'm going to substitute something that y equals, which is 3x. So it's going to be 3x equals negative x plus 4. Now I have an equation that only has x's in it, no y's, which means I can now solve for x. So let's see, I got 3 x's over here and a negative x over there. So I can get rid of this negative x off the right side by adding x, because negative x plus x is 0. And then I would just have 4 left on the right side. But if I add something to the right side of the equal sign, I have to add the same thing to the left side of the equal sign. That way my equation stays balanced, and this equal sign down here is still true. So 3x plus another x is 4x. So I can get x by itself now by, this means 4 times x, so the opposite of times x, or times 4, is divided by 4. So 4 divided by 4 is 1, and then 1x is just x. But for this equal sign to still be true, I need to do the same thing to both sides of the equation up here. I divided the left side by 4, so I need to divide the right side by 4. So now it's balanced, and this equal sign will be true. 4 divided by 4 is 1. So I know what x is. The x value of our solution is 1. And remember that the solution to a system of linear equations is the point where the graphs of those two lines would intersect. So I know what the x value is. And now I just need to plug in to either one of these equations to figure out what the y value is. So it doesn't really matter which one you pick. If you pick y equals 3x, it's going to be y equals 3 times 1, which is 3. If you pick this equation, it's going to be y equals negative 1 plus 4, which is 3. So the answer to this system of equations is the solution 1, 3, the ordered pair 1, 3, meaning over 1, up 3 on a graph, over 1, up 3 on a graph is the point where these two lines would intersect. It would look sort of like this, negative x plus 4, kind of like that, 1, 3. So you don't have to do the graphing for this section. This section is just doing it the algebraic way. I just wanted to remind you what this solution indicates if we're thinking about a graph. I want you to be able to think about both situations. So number 8 looks different, doesn't it? We don't have y equals something or x equals something. So substitution is not going to be quite as easy as it was on the last problem. So what I'm going to do is I'm going to separate these two for a minute and try to figure out which one of these variables is going to be the easiest to solve for, x or y, and which equation. And so I'm going to run you through my thought process here. So if I was going to solve for this y, I would have to add 9x to both sides and then divide by 2. Basically, the only thing I really care about when I'm looking at which variable to solve for is, what am I going to have to divide by? I would have to divide by 2, right? So everything is going to get divided by 2. And then my question is, do things come out pretty or do things come out ugly? And negative 69 over 2, I mean, it's not super ugly, but once you have fractions or decimals in your equation, it starts to throw things off sometimes. So I'm going to put this y on the back burner for now, and I'll check this x. if I was going to get this x by itself, at some point I would have to divide by 9 or negative 9 to get that x all by itself. 69 divided by 9, does that come out even? 69 divided by 9 is a disgusting decimal. 7 2/3. 7.6 repeating is 7 2/3. So this would give us fraction time, which I am going to put on the back burner for now. I'm going to see if there's something easier. If I wanted to solve for this y right here, at some point I would be dividing everybody by 4. So what kind of numbers does that give me? If I do 54 divided by 4, I get 13.5. And 6 divided by 4 is going to be like 1.5. Okay, so there's still some fractions there. And if I was trying to solve for this x, I would have to divide stuff by 6. And this would be 1. 4 over 6 is 2/3, and 54 divided by 6 is 9. So that's the only one where I get a whole number. So it looks like this x gives me the least amount of complications when I'm picking a variable to solve for. So let's solve this equation for x. So the first thing I'm going to do is I'm going to get the y on the other side. So right now it's minus 4y, so the opposite of that is plus 4y. So negative 4y plus 4y is 0, so I would be left with just 6x on this side of the equal sign. But I did add something to the left side, so I need to add that same thing to the right side so that everybody stays balanced. So 54 plus 4y, those are not like terms, so I cannot combine them. So it's just 54 plus 4y. So my next step to get x by itself is to divide by 6. So divide by 6. 6 divided by 6 is 1, and 1x is x. Divide the left side by 6, I got to divide the right side by 6. And notice that I had to divide the whole side by 6, not just one or the other number. Which is the same thing as saying 54 divided by 6 plus 4y divided by 6. So 54 divided by 6 is 9. And then 4 over 6 reduces to 2/3. So 2/3 y. So now I have something that x equals, which means I am now allowed to substitute this expression in to the other equation in place of x. So let's do that. So here is this equation, and I'm going to substitute the expression we got here in place of x. So negative 9 times 9 plus 2/3 y. 9 plus 2/3 y. Okay, so that was just the x. Now I still have a plus 2y on this side. Plus 2y equals negative 69. Now I need to do some algebra. Negative 9 times this whole deal means I have to distribute. So I'm going to distribute the negative 9 to both terms inside the parentheses. Negative 9 times 9 is negative 81. Negative 9 times 2/3. Let's go off to the side and think about what negative 9 times 2/3 is going to be. Negative 9 is the same as negative 9 divided by 1. Anything divided by 1 is itself. And then when we multiply fractions, we do top times the top, bottom times the bottom, and then we can reduce and see what cancels out. Or we can do kind of both of those steps at the same time and just say, I can see that there's a factor of 3 down here, and then I know that 9 is 3 times 3. So if I think about 9 as negative 3 times 3, or I think of negative 9 as negative 3 times 3, then I'm going to now cross this out. What happens? 3 divided by 3 is 1, so these divide out. And what am I left with? on the top, I got negative 3 times 2 is negative 6. And on the bottom, 1 times 1 is 1. And negative 6 divided by 1 is negative 6. So when I do the negative 9 times 2/3, I get negative 6. And it was 2/3 y, so that's negative 6y. And then plus 2y equals negative 69. Now I've got like terms on the left side. Since they're on the same side, I can just put them right together. Negative 6 plus 2 is negative 4, so that's going to be negative 4y. And I still have negative 81 minus 4y equals negative 69. My goal is to get y by itself, so I need to add 81 to both sides. See, I'm adding it to the left side of the equal sign and the right side of the equal sign. It's going to cancel here. Negative 81 plus 81 is 0. 0 minus 4y is negative 4y. Negative 69 plus 81 is basically 81 minus 69, which is 12. Now I need to, this is negative 4 times y, so I'm going to do the opposite of times negative 4, which is divide by negative 4. And I have to do it to both sides of the equal sign. Negative 4 divided by negative 4 is positive 1, and 1y is y. And then 12 divided by negative 4 is negative 3. So I got half of my answer already. I'm going to make a little box right here for my answer to go in. Ordered pair, and I know the y value is negative 3. And to finish off, I need to find out what the x value is. Since I know what the y value is, now I can substitute this negative 3 in for y right over here. Or right up here, or right here. It doesn't matter which equation I use at this point. Once I know what y is, I can plug it into any equation. And I'll go ahead and plug it into here, just because it starts with x equals. So x equals 9 plus 2/3 times y, but y is negative 3. So that's 9 plus, now negative 3 is 3 over 1, so 2 times negative 3 over 3 times 1, or we can look and see that this 3 divided by this 3 is going to be 1, so those will cancel. So I get 2 over 1 times negative 1 over 1, that's 2 times negative 1, which is negative 2. And 9 plus negative 2 is 9 minus 2, which is 7. So the solution to this system of equations is 7, negative 3. So this is the point on the graph where the graphs of these two lines would intersect. Alright, thanks for watching. Talk to you later.